Hey, how's it going? I'm Mark. Welcome back to my studio, or if it's your first time here, welcome for the first time. I'm going to work on a kind of a short project today. I think I can get the whole thing done kind of in one sitting here. So I thought I'd record it and bring you guys along for the ride. I'm going to design and 3D print a custom piece that's going to help me with a camera mount. So before we get to that, I'll give you some background info. Here in my studio, if you've seen some of my videos in the past or any of my live streams, you'll know that I have a camera up here above my build desk that points down straight onto, whatever I'm working on so that you can see that. In the past, it's been just a webcam, like not a cheap one, a pretty decent webcam, but I've never been super happy with the quality of the images, the video that it creates. And so just recently I was looking around and I managed to find myself a good deal on a used mirrorless camera. Let me try to pull it down here into the shot so you can see. It's a Sony mirrorless camera. It's not super expensive, but it's going to work a lot better than the webcam that I had here before. And so, as I've been setting this up, what I've done is I found this arm. It's actually mounted up there behind me on this shelf. And this is a microphone arm, actually, that I had been using for a microphone in the past that I'm not using for that purpose anymore. So I thought I'd repurpose it to put the camera onto it. So it turns out that the end of this microphone arm, the threading that was here, matches perfectly with just a regular tripod style ball mount for a camera. And so this is going to work out really well for mounting the camera on here. And the thought was, if I put the microphone, the boom arm up here on this shelf, this actually becomes not just an over the desk camera for me, but I can pivot it around the corner. Over there is my airbrush station. Back there is all my 3D printer stuff. So wherever I am in the studio, it should be fairly easy for me to move this boom arm around and get the camera pointed to where I am. So I can film video from other places besides just here at my desk, which I think will be useful. Now, the problem so far that I need to solve today is that I haven't used this yet for any filming or streaming or anything, because when I get this locked into place, right, if I put this down here so that it'd be pointing at my desk and I kind of move it around and I get it in a good spot, I'll just put it out here so you guys can see the camera. When I let it go, it does that, right? So the problem is this is a tension arm, and I've got the tension loosened as much as it can go. But the microphone that was on here previously is much heavier actually than this camera. And so the camera doesn't provide enough weight to counterbalance the tension on the arm, and it wants to pop back up, especially if I move it to certain locations. So what I'd like to do is design some kind of a collar that fits around this cylindrical bit right here that will allow me to add some counterweights. So I went looking around at my local hobby shop, and I found these. I got, I think, 20 of them altogether. They weren't very expensive. They're little tungsten weights, and they're designed, I think, for soapbox derby cars. So you can weight those down, so they go down the track faster. So I got a handful of those. Like I said, I'm pretty sure I have 20 of them. And just kind of holding them in my hand by weight, I think that's going to be about the right amount of weight that I need to add onto this arm here to be able to weight the camera down so that it moves nice and smoothly and then holds its position when I let it go. So that's the plan for today, is to build a cylindrical piece that fits around this thing. And there is a little, this little brass screw right here creates like an indentation. We're gonna have to build a little space in the piece for that to fit around that piece. And then I'm gonna build some cylindrical openings in it so that we can basically hang these magnets, all 20 of them. So probably 10 cylindrical holes where we can stack 2 each. And we'll put them around the outside of that cylinder and, create enough weight to make this work. At least that's the idea. We'll see how it goes. And so normally at this point, well, first of all, I've already taken my digital calipers. I've measured lots of things. So I have all the diameters of those different cylindrical things that we're going to have to work in and around. I have the dimensions of these weights. So all of that is ready to go. I've sketched out kind of an idea of what I want to design here on a piece of scratch paper, but I don't have a lot of details about it. We'll just figure that out as we go along. Normally, I would break open Blender and 3D model, something and then send it to my printer. Today, for the very first time, I'm pretty sure on the channel, and probably about only the third or fourth time in real life for me. I'm going to use something other than Blender. I'm going to use a program called Plasticity. It's kind of new. You might have heard of it. It's something I've been wanting to try out for a while. So I'm going to open up Plasticity. We'll jump into that on my computer and we'll model something that hopefully will hold those counterweights and work here to balance out my camera arm. So let's jump into that and see how it goes. Okay, so here we are in Plasticity, and I'm not going to do much tutorial or anything like that, even though I know this is the first time I've shown this application. It's fairly straightforward. I think you'll see as we go along that it's pretty simple to use. I will say, if you're interested in seeing more content related to Plasticity versus Blender here on the channel, leave a comment down below and let me know. One thing about Plasticity is that it's not free like Blender is. So part of me for like the Blender Gunpla series, which has been going on here on the channel and is kind of on hiatus, part of me wants to switch that over to use Plasticity instead because I think it's a more fun and more promising piece of software to use. But I know it's not as accessible for everybody. So if you have a opinion on whether you'd like to see Blender or Plasticity or some combination of both on the channel going forward, definitely let me know down in the comments below, because that'll be helpful for me for my planning purposes. But for this, we're just going to start by creating some circles so that we can create this cylindrical piece we need. So I can drag this out, and if you hit tab in Plasticity, you can type in exact dimensions. I know I need this big cylinder to be 55 millimeters, so I'm going to have to zoom out a bit so we can see it. There we go. All right, so that is our big cylinder, and then I'm going to draw another circle in the middle here that has to be, what is it, 23 millimeters, and that's going to be the hole in the middle. So with that, let's actually go ahead and select this face, and I'll extrude it up. And down here I can type in an exact dimension again, and I know I want it to be 28 millimeters high. So that is going to be our main cylindrical piece. Now before I forget, there's that cutout in the bottom that we need to create. So let's do that here. We can actually delete these two temporary circles that we had drawn because we don't need them anymore. We're going to draw a new one here, and we're going to make this one 29 millimeters in diameter. So this is the area that needs to cut out, and it needs to be 5 millimeters high. So we're going to extrude that up 5 millimeters and lock that in. So we've got this interior, again, I'll delete this circle. So yeah, we've got this interior piece and then this exterior piece. So we'll select those like that, and we'll hit Q to Boolean that out. So now we have that little cutout, which should be perfect for the bottom of this thing. Now up here on the top, we need to create those cylindrical cutouts. And actually what I'm going to do is look at the top view here, and I'll draw myself a little line to use as a guide, right? So I can, if I want to go from here to there, I've now got this line, and now I can use the midpoint of that line to line up my circle. So this snaps, as I drag here, it snaps to middle, and it labels that as middle. So I can drag this out, and again hit tab, and I know this wants to be 10 millimeters in diameter. So that'll fit perfectly right there. Now, I think I want to have 10 of these, because like I said, I have 20 of the magnets, or not magnets, weights, and I want to space them around here and stack them double height, I believe. So what we're going to do is go down here to radial array, and we'll select the center of rotation, which will be just right there, and I can hold down shift and mouse wheel to get, how many is that? 8 right now, 9, 10? Yeah, so 10 fits just about perfectly, which seems great. And now we can select all of those, and I'm going to have to select them all, am I not? Actually, let's go and delete this line first because it's kind of in the way. So yeah, we'll shift select all of these and extrude these downward by 26 millimeters, I think is the correct dimension there. So now we have all of those, and we can just subtract them out of here, right? So we'll select this big body, and then we will shift select all the rest. and difference them out. And there we go. So that's the basic shape we need. Now, for 3D printing, there's a couple of things I'd like to do just to make this work a little bit better. I can already tell this area right here is going to be an overhanging surface. So we want to get rid of that for sure. And I'd like the bottom edge of this to be a little bit better as well. So I'm going to select both of these and just drag here to create a fillet. And I don't want to fillet it by a lot. I think I'm just going to go like one millimeter here, just to give it a little bit of a dimensionality. And then this inner one, I'm actually going to pull it all the way out so that it becomes a 45-degree angle. So that's going to have to be at -3 here to be perfect. Because that way we never have an overhanging edge, right? The printer will be able to print that slope going up at a 45-degree angle. And this will still work fine for sitting on top of that cutout, that little screw area that we need to sit on top of. So that'll be perfect. So I think this is good. Like I could put fillets or chamfers on these edges up here at the top as well, just to smooth them out. But I like them sharp, I think, and just the process of 3D printing and our nozzle width will actually slightly round those edges anyway. So yeah, I think we're good. Just kind of looking around at it, making sure everything looks okay to print. And I think it does. So I'm going to go ahead and go over here and say export. We're going to export this as an STL, so you can save straight to STL from Plasticity now, which is nice. I'm just going to call this Counterweight. And like other operations in Plasticity, when I hit save here, it actually hasn't done the export yet. It's showing us what the mesh is that it's going to create. And then we can play with these parameters down here. So first thing, the default density is 0.5. I'm just going to whack this all the way up as high as it will go, which I think is 1.0. Yes, it is. And you can see it added a lot more geometry here, which I am totally fine with and will help smooth out the edges of our circles. The rest of these parameters, you can play around with these and you can see the changes happen in real time on the mesh example, that it's drawing here. But I'm happy with all the other defaults. So I can either hit enter or click this OK or just right click to confirm. And once I do that, now the export has happened. So I have that, that file now. I'm going to switch over to my slicer and just import it here. So let's import our counterweight that we just saved. And there it is. Looks good. Yeah. It's going to be totally fine, I think. So I'm just going to slice this with my default settings. I'm printing this in ABS because that's just what happens to be loaded into my printer right now anyway. We can go under here and see that there's no overhangs. There's no blue here on this that area. So that looks really good. Yeah, I think that's going to be totally fine how that prints. So yeah, I'm happy with that. I'm going to go ahead and send this over to the printer. It's going to take about an hour to print, and so I will pull that off the printer when it's done, and I'll come back and show you guys how it turned out. All right, we're back. The print's finished. I just pulled it off of the printer back there. It's actually still a little bit warm, which, by the way, you should let your prints cool fully so that they come off the bed nice and clean rather than ripping them off of the heated bed. This one came off okay, but yeah, I was impatient. I had a video to make, so I went ahead and pulled it off of the printer a little bit probably before I should, but came out good. Yeah, I don't know if it fits yet. We're gonna figure that out right now. But yeah, this looks good. Let's grab some of these weights. These are weights. I called them magnets, I think, a couple of times earlier on. Yeah, they fit nicely, which is good. The reason that I called them magnets is because they remind me of like the 6mm round magnets. Of course, they're taller than that, but yeah, they remind me of the standard 6mm round magnets that you use for like Gridfinity, or they're used in several of the parts for the Voron printer that I just built recently, all of that kind of stuff. So that is the reason why I may have misspoken several times earlier and called them the wrong thing. They are fitting in here nicely. Now, of course, if this part was ever meant to like tilt, it's going to sit vertically like this, but if it was ever meant to tilt in some other way, we would have had to design some sort of top or something for these things. But I'm just going to let them drop in here and let gravity hold them in place. It'll be fine. So yeah, this is nice and heavy. This is this is promising. I like how this is turning out. Let me see if I can get this in the shot for you guys to see. So I did go ahead and unplugged all the wires and took the camera off before I started this little session here, but we will disassemble the rest of it now and try to get this counterweight in place. So this comes off, and then of course we'll have to put the camera back on because I need to see how the weight of the entire assembly is with the camera on the end of the arm here to see if it's really going to help. So yeah, this should now slide right on there, which it does. And there's a little bit of a tolerance, like we could have probably made that center hole a little bit smaller, but it's fine. And then this should screw all the way up here. And then when I let this go, it drops and falls, yeah, with that cutout perfectly in there. So that's great. Now this can screw on next. Get that nice and tight there. Excellent. All right, I can already tell that it's heavier. Of course, without the camera on here, it still, as soon as I let it go, wants to spring back up. So let me grab the camera, and being careful not to drop the camera, which is new to me. So I don't want to break it like in the first couple of days that I've had it. That would be terrible. Let's get this on here, tighten it down. Oh, look at that. Okay, so that is, I'm not going to hook the cables back up right at the moment, but that's the full weight of everything on here. So now if I move this around and I put it there and I let it go, it does go up a little, right? You saw that, right? If I put it here and then I let it go, but this is way below the, like what should be expected of the movement of this arm with it mounted that high up, right? I'm doing this to keep it in the shot so you guys can see, but generally it will be over here and up higher and tilted this way, right? And even higher than I can show you here on camera. But if I put it there and I let it go, yeah, it's not moving much at all. And if I put it up there where it's meant to be and I let it go, it's perfect. It's not moving at all. So that's great news. Yeah, I think this is a success. I'm gonna call this a success. It looks nice too. It looks like it's meant to be part of the arm here. This is the cylindrical bit right here that we just created. So yeah, that's really excellent. I'm happy with how that turned out. Cool. So what did we learn? We learned I like plasticity. That's the first thing. That was the first time I've ever like really used it for a real project, right? It was super simple to use. I've only ever played with it for like maybe half an hour before today. So yeah, the fact that I was able to do, it was a simple thing, but I was able to do that pretty quickly. It's probably a testament to how easy plasticity is to use. I'd like to use it more in the future. Like I said, on the channel or not, I'm not sure, because of it not being a free piece of software, so I'm not sure how accessible and easy it would be for you guys to go and try some of those same things if we used plasticity for, you know, gunpla parts and things like that. So I'll think about that some more. But yeah, plasticity, fun to use. 3D printing your own custom parts, right? For anything, right? If you need like a little cable management solution or an adapter for something or a way to mount some piece of equipment or something somewhere, take some measurements and model yourself a little part and print it out. And yeah, it's one of my favorite things I think about 3D printing is you can just custom make these little one-off things that you know, make things simpler or cleaner or make your life easier, which is great. So yeah, definitely do that. If you've never thought about using 3D printing as, you know, a way to make your own little adapters or mounts for things or whatever, give that a shot. It's great fun, and it's a great functional way to clean up your space and do things like that. So yeah, with that, I guess we're done with this project. It's a success. I'm happy with it. I hope to use the camera very soon for some, you know, actual footage here on the channel. We'll see how that goes. There's still some settings and stuff I probably have to tweak to get it ready to go, but at least now it stays where I want to put it, and that is the first step. So yeah, hope to see you soon, either on a stream or on a video like this with that camera actually shooting some of the footage. So until then, hope you have a good one. I will see you next time.